Hello, today's video will help you find, open, and review files in R. Please make sure to download the Intro to R script as well as the related data sets. Before we get started, I also want to note how we are keeping notes and how we are looking at this R script. So as you can see at the top here, many of these lines start with a hashtag. When you see a hashtag in front of some R script, this means that this is commented out and R cannot read these pieces of script. So therefore, these commented out sections are areas where notes are happening. And you will see this throughout the script where I have given notes for you for a little bit more detail or reference about a particular place in the script. You are welcome to add to these notes with your own notes so that you can remember what's been happening. As always, please feel free to ask questions by emailing me at the email address on top. As we go through the script, the first thing that we need to do is to be able to actually work from our script and be able to open up files. So in order to do that, it's helpful to be able to know where your files exist. Prior to working with this script, I downloaded my files to a folder on my computer, the address for which is located here on line 50. I'm a Mac user, so this is the way that I would identify the path in which the folder exists. For my PC users, the way that we identify how a folder is written is listed here on line 47. This address is the place where R will use going forward all the information as a working directory. A working directory is temporary for the R session, and it is the location where R will take data or share uploaded data to that site. So in this instance, I will be working from the following address, and I'm going to go ahead and run this. In order for me to run it, as a Mac user, I would press Command Enter. My PC users can press Control R or Control Enter. Or if you don't remember what to press, you can always look on the top of your editor and you can use the Run button and press that here. The Run button will run the current line of code and nothing else. If you wanted to run more than one piece of code, you can always highlight multiple pieces of code that you want to run and run those as well. So what you can see here is that we ran the code that identified the address where our data live, and we asked to confirm that in fact R is getting that information from that location by using a statement called getWD. And what you're seeing here is that information is being placed in a console. This console acts as a log for all of the steps that you've taken during that R session. So if you want something to last for a long time, it's best to write code in your editor, and this is the one that I have up here on the top left-hand corner, and you continuously save that. And when you want to see what comes of it, what is being run, you can monitor that through the log on your console. The nice thing about the console is that it's not only telling you what's happened when you run something, but it can also be used as real time whenever you want. Maybe you just want to test a little piece of code out and you don't necessarily want the code to last in your editor and be saved. So you just test it out in your console, like I'm doing here with 2 plus 2, and I'm saying it's 4. So it's something that you can do for small pieces of code that you want to test. So that's for your console or running log and a place where you can test. Permanent things should be written in your script, in the editor. And when we look to the top right, we have a window called Global Environment. Currently, it's empty because it does not have any objects yet, but it will very soon. And when you see that getting populated, you'll see what we're talking about. Also on the bottom right hand corner, there are several windows where you have at this point a running log of any plots or figures that you might be developing. You also have the files of the working directory that you're working from. And you also have all the available packages that you can download um, or have downloaded to your computer. Also, you have a help file and you have a viewer, which we will talk about in a sec. So you have a lot of things that you can use in RStudio to get yourself acquainted with your files and your scripts. All right, so now that we've set our working directory, we actually want to open a file that lives inside of that working directory. So if we look at lines 57 and 58, they're doing very similar things. In line 57, what is happening is that we are using a function called read.table. This is a very general function that allows us to read an ASCII file, in this case, a file called bmx 2018.csv, and it is being supplied with additional information. The first piece of information is that this file, bmx 2018.csv, has variable names on the top row of this data set. Therefore, we are telling R that top row should be considered as variable names, not as data, or header equals true. If header equaled false, R would understand that to mean that there are no variable names on the top of the data set, and it's just data. The next thing is that as this data set and file live as a comma delimited file, I am letting R know that the separator for this file is commas. So anytime it sees a comma, it is separating that information from the previous information. The other thing that we put in to give knowledge to R so it knows how to handle it is what we are defining as missing, or any dot strings. R understands and codes missing as capital N and capital A, NA. But in other programs where data might have been generated, they might define missing as different values. Some people define missing as 999, other people define it as dot. In this case, the file defined missing as a blank space. And so that is what we have identified here. And so R understands that when it sees a blank space, it is meant to translate into a missing value, or NA. Once it reads the file with all of these definitions in place, it takes that information and then sends it to an object that will live in the working directory called bmx. A similar step is done for developing an object called demo and just opening up a file called demo2018.csv. So now we've opened up our file. Well, we actually haven't opened up our file. Now we're going to run these two lines and open our files and send that information to the objects bmx and demo. You see nothing happened at the bottom of the console, but the lines of code did run. We just didn't get any information that it worked. And we usually get information on the negative side of the thing didn't work. Maybe you received some sort of warning to bring your attention to something. In this case, it looks like everything was successful. We can begin to confirm this point by doing a couple of things. First, if you look at the top right-hand corner, you can see in the global environment that you have an object called bmx and one called demo. And it has the related number of observations and variables. The other thing that you can do is you can use a term called LS or list. This will list the objects that are located inside of your working directory as temporary objects. And you can see that we have an object called BMX and one called demo. Now, I know previously that I would be able to merge these two objects together. And so I'm going to do that now on line 69 so that I can continue working with these data. I wanted to do this because I wanted to bring attention to a really great function called merge. In this line of code, we are merging two objects, BMX and demo, by a common variable that's in both of the data sets called seqn. There are a lot of details that I have not put in this particular line of code just because I wanted to keep it simple. However, this merge function is extremely powerful and you can do inner and outer joins with this merge function. You need only define it that way. I wanted to bring this to your attention because this would allow you in the future to take some more time to play with merge and try a couple of different tricks. So please follow up by learning more about merge using question mark, merge, open, close parenthesis, and pressing the run. You see that you have two different types of ways to merge data. In this case, we're using base R. So we're going to use the package that's in the base R directory, and we will see how merge works. So now you see that the bottom right-hand corner helps you see some of the information using the help files from R. And with that, I will leave it to you to play a little bit more about with merge and merging data going forward. Okay, now we're going to move into getting a feel for the data. If you have not run line 69, go ahead and do so that we can merge those two objects. And if you have merged those two objects, BMX and demo, you now have a new object called full data. You can see it up here in the top right-hand corner, and it has 10,253 observations and 65 variables. So now that we've made this new object called full data, we'd like to learn more about it. We'd like to know what kind of data are in it and what, and actually do things with this object. So how do we learn what's in a data frame? It's always good to do a couple of steps. There is certainly one thing that you can do, and that is go to the top right-hand corner and literally click on full data. This will allow you to view the object full data in its entirety. You can see all the columns. I'm just scrolling down a little bit. And you can also see all the columns and all the rows. I've shown you a couple of the rows, and now I'm going to scroll to the right to show you the first 50 columns. If you want to see more columns, you just use your right arrow and you can see more of those columns to see what the data set looks like. And this is the last variable in that data set. So that's one way to see what your data look like. Another way to do it is to code for it and begin to understand the structure of your data set. So we can use a function called dim that will tell you the dimensions of the data set. And as we've seen before, is over 10,000 observations and 65 variables. This function is returning the number of rows and the number of columns in your object. The next thing that you can do is to really know what are all the variable names in your object, full data. using the names function. So on line 89, I'm running the names function, and you can see all of the variable names listed here. One thing you should note are these numbers on the left-hand side. These numbers correspond with the variable names in the data set. So seqn is the first column in the object full data. BMD stats is the second column in the object full data. BMXHT is the ninth variable in the object full data. And SDMSTRA is the 65th column in this object full data. Another way to look at your data is to just look at the first 6 observations using head, which you have here. Or you can see the last 6 objects using tail. You can also see the structure of the object full data, kind of like a table of contents for your object full data using the str function, which we have here. And similarly, it allows you to see some of the first rows of information for each of those variables, as well as the variable type. As in seqn, it's being read by R as an integer. BMXWT is being read as a numeric variable and with corresponding values for the first several rows. The other thing that you can see is that this object is of type data frame. There are several different types of objects in R, and we will talk a little bit about those later on. This particular object is defined as a data frame, which is very typical for many of the data sets that we'll work in going forward. Another way to get a sense of the variables of themselves, their distribution, is to use a function called summary. If you run line 104, you can see that you have now taken the basic summary statistics across all of the variables in the data set, in the object full data. So we're going to look at the last variable, SDMVSTRA, and what we can see is the mean of that column is 81.43. It has a max value of 89 and a min of 75. So it helps you to understand basic distributions across all variables. But you may not want to look at all of your variables at the same time. It can be quite a lot of information when you're scrolling through all of your variables. So if you want to hone into a particular variable inside of a data set, what you would ask R to do is say, I'd like for you to take a look at a specific object. In this case, we're looking at the object full data. And I want you to take one element inside of that object. In this case, the variable rid age year or age. It understands that you are talking about a specific element because it uses the $sign. So the order of operation for trying to tell R to look at a specific variable by name is object name, $sign, variable name. We're now going to take a look at a table of counts of the variable rid age year on line 111. So here you can see the number of people who have these various ages across the entire data set. And similarly, if you wanted to find more out about the variable age year, you might want to know the mean of rid age year. So you could use a function like mean. And if you run line 122, you can see that the mean of RID age year is about 32.57. Now, I also want to take a moment to give you some finer details about functions and how to learn more about functions. So let's run line 125 and get the mean of weight. When you see the mean of weight, the value is NA, which may be confusing because surely there should be a mean value for weight. But it's possible that there may be missing values in the weight variable. When R sees a missing value, especially when it's calculating certain statistics, sometimes it puts value on missing. And when it sees missing, it basically says, I can't calculate the mean of missing. So I'm going to make the mean missing. If you're unsure of what's happening and you're trying to troubleshoot yourself when you're alone, one way to confirm this issue is to run something like that summary function on the weight variable and check to see if they're missing data. And yes, indeed, there are 91 observations with missing data. So you can then go to line 138 and say, I'll account for missing, and I'll just tell R what to do with missing. And in this case, what you do is you add on to that function mean, and you put another statement at the end that says na.remove or remove missing equals true. So yes, R, anytime you see a missing value, please remove it and do not include it in the calculation. You can go ahead and run it and see what happens now. And oh yes, we are able to calculate the mean. But what if you're by yourself and you get some sort of message like that? What do? Two things. You have a choice of starting with the help, and again, to bring your attention to how you look for help, question mark, the name of the function, open close parenthesis is all you have to do, and voila, you can take a look at some of those details, and oh look, it has mention of this term na.rm, and it explains to you what it's doing. So that's one way to do it. And another way, honestly, is to start looking up information on the internet. At the bottom of this script, I've shared resources that I found super helpful over the years to understand what's happening when I see an error message or I'm trying to learn more about a particular function. So all of that's down there, including specific search engines that you can use for looking and doing searches specific to R. All right, it's now time to introduce a new function. So we've learned about several functions already, but we're still needing to learn more about our data and get a sense of what's going on with our data. Also, I wanted to give an opportunity to share a way to start incorporating all of these wonderful packages into your R session. As we've discussed before, one of the most powerful things about R is that it has so much functionality, and that's via all of these various packages. One such package is called the psych package, and it has a lot of great functions to do some basic analyses, and describe as one of those functions. So first, in order for us to be able to use this describe function, we need to download the psych package. So we'll go down to line 156 where it says install.packages. Here, you're going to go to an R repository, also referred to as a mirror, and you're going to download a package called psych onto your computer. Also, sometimes packages are run or built using information from other packages. Therefore, the package you want may be dependent on other packages. If you're unsure, it's always great to just put the next term where you say dependencies equals true, which tells R if there are other packages that this package is dependent on, please download those packages as well. Once you download those packages of interest, once you run line 156, you might be asked to choose a mirror, and you'll just choose whichever location feels good to you. There is no hard and fast rules to make that happen. And once you've downloaded your package, then you can check to see if your package was actually downloaded in this package tabs on the bottom right hand corner. So I'm going to scroll down by alphabetical order, and you can see that, the psych package has in fact been downloaded. Now, once it's been downloaded, you still can't use it in an R session. You have to call it up for each new R session that you're using. So at this time, psych has not been called up. I need to run psych and actually make it work in my session of R using this library function. Another popular function to make packages work is called require. So I'm going to run this library function. You see that I've got some red code, and we'll talk about that in a second. But what I also want to bring your attention to is if you look at the right-hand corner, you now see that the psych package has been checked off. I certainly could have checked psych by itself, but I think it's really helpful to be able to code these things up front and reduce the amount of work that you have to do to remember things if they're already coded for you, if you've done your coding ahead of time. So now that I've opened up the psych package, I can use it in R, but it's also telling me a couple of messages. Red doesn't always mean bad. Sometimes it's just trying to tell you things. And in this case, R is trying to bring me some attention on a couple of points. It says, the following object is masked from package polycore, and it's polyserial. And what it's trying to tell me here is that I have two packages open right now. One package is called polycore, and I just opened up a package called psych. Both of these packages have a function called polyserial, but R won't know which polyserial to use. And so what it says is, I will use the polyserial function for the package that was most recently opened, in this case, psych. Therefore, user, if you decide to use polyserial in this session, please remember that you're using polyserial as coded by the psych package, not the polycore package. And that's what it means to mask an object from another package. So this has happened for a couple packages, and it's also telling me that it was built under a different version of R than what I have, but it shouldn't change my functionality at all. Once we have uploaded the packages, we've opened the package, we can now finally use the describe function that we have in line 160. And we can take a look at this rid age variable one more time. And as you can see, it's a lot of summary statistics still. It's a little bit more than what you saw with the summary function, but it helps you to understand what this variable looks like. This concludes this part of the video to help you understand how to open up files and how R thinks about files and the notion that R functions within objects. In this instance, we took information from our files and we moved them into two objects, BMX and demo. And then we merged those two objects into one third larger object called full data. This full data contains several elements. One of the elements that we just looked into was rid age year. Every element is representing a variable in the original data set for which we might be interested in analyzing. And that is basically how R begins to think about problems and saves problems in its working directory and does its analyses. Thank you so much.